Welcome back to Dilemma's Concept. Today, what we're looking at is another add math question, but this one is a trigonometric proof, right? So let us take a look at it. It says, using an appropriate double angle formula, derive the identity for sine of 2x. Now, what we're gonna have to do with this is that we gotta go back to basics. For example, if we have the sine of a plus or minus b, it is equal to sine of a times cos of a plus or minus sine b cos b. That's what this is. So with this, we're able to manipulate this now in order to suit ourselves. For example, I'm going to focus on this 2x. So I'm going to take this and I'm going to say sine of x plus x. So as you can see, I'm manipulating that. So I'm using sine x 2 times. So this is 2x, right? So this is equal to sine x cos x plus sine x cos x. As you could see. Now what this is basically 2, right? So this is 2 sine x cos x. It's 2 of it. This, as you could see, is sine 2x. So this is what we just came up with. The identity, one of the identity for sine of 2x is 2 sine x cos x, right? So we could do that and we're good. Let's take a look at the other part of the question. So the other part of the question says, hence prove the identity 1 plus sine 2x over sine x plus cos x equal to sine x plus cos x. The moment they say hence here, it simply means that I'm going to have to refer back to the solution that I just got. So I'm going to have to refer back to this solution right here, this, because I could now substitute here where I have 2x, right here where I have the sine 2x, I'm going to put this there. So I'm going to rewrite everything. So the bottom line is I'm going to focus on the left side and I'm going to use it to prove this side on the right. Remember though that the sine of 2x will be substituted, right, as 2 sine x cos x. Let us get into it. Also, another thing I want us to pay attention to. So these are our 2 things. We want to recall that the sine of 2x is equal to 2 sine x cos x. Also, we want to recall that sine square x plus cos square x is equal to 1. We also want to recall that sine square x plus cos square x is equal to 1. So we could start our substitution here. But remember now, I'm going to use my left side to prove this right side. So I'm going to substitute 1 here for this. So here, I'm going to substitute sine square x plus cos square x. And I'm putting that for number 1 here. Also, instead of writing sine 2x, I'm going to have 2 sine x cos x. So it's going to be plus 2 sine x cos x. And all of this is over sine x plus cos x. Now remember the objective. I'm taking my left side and I'm going to show that it is the right side. Now, if this is like squaring a binomial on top here, take a look at the idea. If I have a plus b and it is squared, this is my result. I'm going to get a squared. Also, I'm going to have plus 2ab plus b squared. Now, that means this is when you square a binomial, which means that this binomial was multiplied by itself. It gives this. So, what am I seeing? Take a look at this. At the top, the numerator, I'm actually seeing this. So I'm going to rewrite the numerator with this idea, right? So I'm going to actually say, okay, this is actually sine x, right, plus cos x times sine x plus cos x. Because if you should multiply this, you're going to get all of this here on top, which is similar to this idea. And this is over sine x cos x. As you could see, because the numerator is multiplying, I could cancel one of these with one of that at the bottom. And then what it is I'm left with, I am only left with sine x cos x, which is what they asked us to prove here on my right hand side. So we were able to prove that identity there. Thank you for watching Daddy Mas Concepts, and see you next time where we will be looking at more videos. Bye-bye.